Assalamu alaikum students. Hope you all are fine and doing well in your studies, and Edmodo group is helping you a lot in this matter. So today we are practically starting our lesson that will be related to the objectives that I had already shared with you in Edmodo group, and our lesson is related to the identification of cations and anions. The identification of cations and anions is related to the salts that you have already learned, related to salts. That's why I conveyed to you a message that you have to memorize the solubility rules. For salts, as you are all aware that salts are ionic compounds. These are ionic compounds. Those contains the positive ions and negative ions. The positive ions are commonly known as cations, and the negative ions are commonly known as anions. So here we go, and we will start our lesson from the cations identification and anions identification. For cations, we have two types of cations. One are known as colored cations, and second are termed as colorless cations. Colored cations. If you can memorize the metals, so the metals were are of two types, means two types in which way, like group 1, 2, 3, and secondly we have transition metals. If you can memorize the properties of transition metals, so one of the property was form colored compounds. So from this property we can say that all the colored cations, means all the positive ions that form colors, will belong to the transition metals. So colored cations that are in your syllabus, these are iron 2, Fe2 plus, iron 3, Fe3 plus, chromium 3, Cr3 positive, and lastly we have copper 2. Cu2 positive. Each of the cation form its distinctive color. We will see that what type of colors they will form. And talking about the colorless cations, they are not colorless cations, they form white precipitates. Precipitate is not a new word for you. You had already learned about this in insoluble salts formation. Over there, the insoluble salts form precipitates. So, all these colorless cations form white precipitates, and those are calcium ion, aluminium ion, zinc ion, and ammonium ion. These are the colorless cations that you will study in the identification of cations. So, four are the colored cations, four are the colorless cations. Now, how can we able to identify them? There are two reagents that we will use to identify these cations. Means basically identification is related to the test. Identification means tests of these cations, just like the test of gases, just like the test of gases. For example, you have learned about the test of hydrogen gas. Test of hydrogen gas means initially you use lighted supplant, and what is the observation? Hope you have already in your mind that what are the tests of all the gases and what are their observations. So it extinguishes, producing pop. So we were talking about the reagents that we will use, just like over here the reagent is lighted supplant. Similarly, for the reagents used to test cations. So the first one is aqueous sodium hydroxide, and second one is aqueous ammonia, or you may say that ammonium hydroxide solution. So what about the hydroxides? What did you say? Alkali. So these are alkalis that we have. And sodium hydroxide is a strong alkali, whereas ammonium hydroxide or aqueous ammonia is a weak alkali. So these two solutions we are using to test for cations and only cations. Now we are going to see that how we will be able to test for a cation and how these two reagents can help us. First of all, you have to keep in your mind that when we will add the reagents in the aqueous solution of cations, they will produce specific color precipitates. Those precipitates will be the hydroxides of these metal cations. So I will ask from you after we will start writing the test for our identification for these cations, that what kind of hydroxide will form if that ion or that cation is reacting with the sodium hydroxide or aqueous ammonia. Now we will proceed further in order to check like what kind of results and what kind of precipitates will form when we will write for these cations. So starting with the colorless cations, identification of colorless cations. I am forming a table. In this table we will write the reagents. First reagents, second one calcium ion, aluminium ion. Okay, the first one we have reagents. Now we have calcium ion, then aluminium ion, then zinc ion, and lastly we have ammonium ion. First part, add few drops of aqueous sodium hydroxide. Few drops means you can add 2 to 3 drops. Means 2 to 3 drops or 1 to 2 drops. When we are going to add few drops of aqueous sodium hydroxide in aqueous solution of calcium ion, means calcium salt, we have the aqueous solution of calcium salt, and if we are adding few drops of aqueous sodium hydroxide, what we will observe, white precipitate will produce. White precipitates I will write in the form of PPT. White precipitates will produce, because previously we talked about the colorless cations, that all the colorless cations will form white precipitates. So in case of aluminium, white precipitates will produce. White precipitates will produce. Similarly, in case of zinc, white precipitates will also produce. And in case of ammonia, no precipitates will produce. Now for the second part, we are add aqueous sodium hydroxide in excess. In excess means we will add now the more amount, not in the form of the drops. You can add 2 milliliter or 1 milliliter or 3 milliliter or 4 milliliter. Means you can pour more and more sodium hydroxide in it in order to check whether the precipitates will dissolve or not. So over here we will see that those white precipitate that will produce, precipitates remain insoluble. So if the precipitate remain insoluble in case of excess sodium hydroxide, it means that that cation will be the calcium ion. Over here, precipitates dissolve to produce clear solution. Like the water, first white precipitates are producing. Now if we are adding the excess amount of aqueous sodium hydroxide, and these precipitates will dissolve in the water, not in the water, dissolve in aqueous sodium hydroxide, producing a clear solution. Means apparent, there will be no sign of solid particles in it. Over here same is the case with zinc, like precipitate dissolve to produce clear solution. In case of ammonia, means in case of ammonium ion, what will we have to do next? Warm the mixture, bubbles of colorless gas produce that turns moist red litmus blue. So over here there is a test of the gas that I have mentioned over here, like a gas is producing, colorless gas is producing, but what that colorless gas is doing, it is turning the moist red litmus paper blue. Means that gas will be ammonia gas, which is alkaline, and it is the test of that alkaline gas. Now how we are performing these observations, like we are in the first step, we are preparing an aqueous solution of salt containing cation. Means using a salt for the specific cation. Suppose we have the calcium chloride and we have dissolved it in water and form a aqueous solution. Now first part of solution means we are dividing it into two parts, and second part of solution we have divided the aqueous solution of the specific cation, whether you have made it for the calcium ion or aluminium ion or zinc ion or ammonium ion, we will divide it into two parts. For the first part, we will take it in our test tube, and this is a test tube, and we will perform the first series of test with aqueous sodium hydroxide. Now with the second part, we will take it in our test tube and will perform a second series of test. Why we need to perform the second series of test? We will see why. Like, considering for the calcium, white precipitates are producing that remain insoluble in aqueous sodium hydroxide. Means we can identify if the precipitates are insoluble, white precipitates are insoluble or remain insoluble, it means it's a calcium ion. And if the white precipitates are not producing, and we will further warm the mixture, then bubbles of gas means ammonia gas will produce that turns moist red litmus paper blue, it means ammonium ion. But for the case of aluminium and zinc ion, we can say that initially the white precipitates are producing, but in the second part, both of the white precipitates will produce to form a clear solution. It means we cannot identify between aluminium and zinc whether it's an aluminium ion or whether the solution contains a zinc ion. It means that we have to perform the second series of test that we will use with the aqueous ammonia. Now, guys, for the third thing, we are add few drops of aqueous ammonia. Now if we are adding few drops of aqueous ammonia, the first one was calcium ion. So for the calcium ion, no precipitates produce. And for aluminium ion, white precipitate produce. White precipitate produce. For zinc ion, white precipitate produce. And for ammonium ion, no precipitate produce. Now from this identification, no precipitate produce and no precipitate produce, we are further confused like whether this is a calcium ion or this is a ammonium ion. But we have already performed a series of experiment on it that shows that if a white precipitate further produced for the calcium ion, so it would be the calcium ion. Next means the fourth part, add aqueous ammonia in excess, not in a form of drops, we are adding it in excess. So same is the case, no precipitate will produce. If no precipitate produce, then calcium ion is confirmed. Over here, calcium ion is confirmed if no further precipitation is producing. Here, the precipitate remain insoluble. Precipitate remain insoluble for aluminium ion, that you have already seen aluminium ion, and its precipitate in excess of aqueous ammonia remain insoluble. Now what will happen to the precipitates of zinc? White precipitate dissolve to produce clear solution. Now here the difference between aluminium and zinc ion means for the aluminium ion precipitates in excess of aqueous ammonia they will remain insoluble, while again for the zinc ion they dissolve. It means that in the second series of experiment we can clearly identify whether it is an aluminium ion or a zinc ion. So over here you will write aluminium ion is confirmed that this is aluminium ion, and for the zinc ion we will write like the zinc ion has confirmed. Now what we will do for the ammonium ion? There wasn't any sign of precipitates. The same thing we will repeat. The above one means we will warm the mixture or warm the solution. Warm the solution. A colorless gas. Colorless gas means ammonia will produce that turns moist red litmus blue. So it will turn the moist red litmus paper blue. Before the start of the writing these identifications and these results, I told you that the precipitates that will produce will be the result of the formation of hydroxides of these ions, means calcium ion, aluminium ion, or zinc ion, or ammonium ion. So basically the reaction that occurs between the sodium hydroxide and the ion is only the reaction between the hydroxide ion and the calcium ion. Suppose for example I am writing the ionic equation of precipitation. There isn't any difficulty for you to write the ionic equation of precipitation, because in the formation of insoluble salts you have already familiar how to write the ionic equations of these precipitates. Suppose the calcium ion is in aqueous form and you are adding sodium hydroxide in it, and from sodium hydroxide only the hydroxide ion is reacting with calcium ion to produce the precipitate, and precipitate will be its hydroxide, calcium hydroxide solid. Over here the two hydroxide ions, here you will write the two in order to balance it. Similarly, if you are writing for the aluminium ion, so aluminium ion in aqueous form reacting with its hydroxide ion from the sodium hydroxide or from aqueous ammonia or ammonium hydroxide to produce the precipitate of aluminium hydroxide, which will be aluminium hydroxide, ALOH thrice. Over here 3 hydroxide ions are, so we will write here the 3 hydroxide ions. Now today you have learned about the precipitation of calcium, aluminium, zinc and ammonium ion, means we talked about the identification of cations. And from the identification of cations or positive ions, we have discussed only the colorless cations. So this was the lesson that was related to the identification of cations. In our next lesson, we will learn about the identification of colored cations, that how we will go for the colored cations, and you will have to learn from your book, from the chapter salts, in which identification of cations and anions are given, that what could be the possible test for the colored cations. So this is all about the colorless cations. See you in the next lesson, and if you have any kind of queries related to these tests or how can we perform this, you may ask me in a WhatsApp group or through Edmodo.